Cool, this is Module 8, The Science of Earthquakes. In this module, we will go over what is an earthquake, what causes earthquakes and where do they happen, why does the earth shake when there is an earthquake, how are earthquakes recorded and measured, and how can scientists tell where an earthquake happened. This lecture is relatively short but is important because it will provide you with the foundational knowledge for the next lecture, where we learn about earthquakes that are generated by volcanoes and magma processes in Hawaii. What is an earthquake? An earthquake is a sudden shaking of the Earth's crust, typically caused by the abrupt release of strain that has slowly accumulated at a fault. Generally, this happens when two blocks of Earth suddenly slip past one another. The surface where the slip is called the fault or fault plane. The location below the Earth's surface where the earthquake starts is called the hypocenter, and the location directly above it on the surface of the Earth is called the epicenter. Sometimes an earthquake has foreshocks. These are smaller earthquakes that happen in the same place as the larger earthquake that follows. Scientists can't tell that an earthquake is a foreshock until the larger earthquake happens. The largest main earthquake is called the main shock. Main shocks always have aftershocks that follow. These are smaller earthquakes that occur afterwards in the same place as the main shock. Depending on the size of the main shock, aftershocks can continue for weeks, months, and even years after the main shock. What causes an earthquake and where do they happen? Recall from last class that the Earth is layered. The surface of the Earth, also known as the lithosphere, is composed of the crust and the upper mantle. The lithospheric plates, or tectonic plates, move via convection. Through this process, 13 major and several minor plates are constantly moving past each other, beneath or over one another. The edges of the plates are called plate boundaries. The plate boundaries are made up of many faults, and most of the earthquakes around the world occur at these faults. Since the edges of the plates are rough, they get stuck while the rest of the plates keep moving. Finally, when the plates have moved far enough, the edges unstick themselves and one of the faults, and there is an earthquake. In Module 8b, we will discuss how earthquakes can be generated in places like Hawaii, shown here, that are located in the middle of a lithospheric plate. This is known as an intraplate earthquake, but for now, in this lecture, we'll talk more generally about the common occurrences of earthquakes along plate boundaries. What causes earthquakes and where do they happen? The San Andreas Fault, shown here, is one of the most famous examples. In California, there are two plates, the Pacific Plate, shown on the left, and the North American Plate on the right. The Pacific Plate consists of the Pacific Ocean floor and the California coastline. The North American Plate comprises most of the North American continent and parts of the Atlantic Ocean floor. The primary boundary between these two plates is the San Andreas Fault. The San Andreas Fault is more than 650 miles long and extends to depths of at least 10 miles. As the Pacific Plate grinds northwestward past the North American Plate, it moves at a rate of about 2 inches a year. Parts of the San Andreas Fault system adapt to this movement by constant creep, resulting in many tiny shocks and a few moderate earth tremors. In other areas where creep is not constant, strain can build up for hundreds of years, producing great earthquakes when it finally releases. The largest historical earthquake on the northern San Andreas Fault was the 1906 magnitude 7.9 earthquake. In 1857, the Fort Tejon earthquake occurred on the southern San Andreas Fault and is believed to have a magnitude of about 7.9 as well. Why does the earth shake when there is an earthquake? Strain is the change in shape and or volume of a rock caused by stress or pressure. When stress is applied slowly and continuously over time, most rocks will deform elastically, as shown here. meaning they will spring to their original shape if the stress is removed or when the rock fractures. This is known as elastic rebound. The same is true along a fault that may be stuck. The elastic deformation accumulates until the fault becomes unstuck. When rocks break or a fault abruptly ruptures, it releases strain in a form of energy called seismic waves. Seismic waves radiate through Earth's interior along its surface. Seismic waves cause a shaking felt during an earthquake. The seismic waves shake the earth as they move through it, and when the waves reach the Earth's surface, they shake the ground and anything on it, like our house and us. How are earthquakes recorded and measured? Earthquakes radiate seismic energy in the form of two types of surface waves, love waves and relay waves, shown here on the right. There are also two types of body waves, primary or P waves and secondary or S waves. P waves are the fastest kind of waves. It moves through solid and liquid layers of Earth. A P wave pushes and pulls on rocks or liquid that it moves through. S waves, shown here, are slower than P waves and can only move through solid materials like rock. The S wave moves up and down or side to side. The different properties of S and P waves are what allows scientists to explore the structure of Earth's interior. We discussed this just briefly in previous lectures. Seismic surface waves shown on the right are the slowest. Love waves arrive first on the surface of the waves. Love waves arrive first of the surface waves. This type of wave moves through the ground from side to side, leading to widespread damage to buildings, roads, and other solid objects. The relay wave, the second type of surface wave, rolls along the ground just as a wave rolls across a lake or ocean. As it rolls, it moves the ground up and down and forward to backward in the motion that the wave is moving. Most of the shaking felt from an earthquake is due to the relay wave, which can be much larger than any other wave. How are earthquakes recorded and measured? Earthquakes are recorded by instruments called seismographs. The recording they make is called a seismogram. The seismogram records the arrival and size of body waves and surface waves. When an earthquake occurs, the first wave recorded on a seismogram is a P wave, as shown here. The next is a S wave, followed by the surface waves. And remember, the surface waves are the ones that cause the most damage. A short, wiggly line that doesn't wiggle very much means a small earthquake, and a long, wiggly line that wiggles a lot means a large earthquake. The length of the wiggle depends on the size of the fault, and the size of the wiggle depends on the amount of slip. The size of the earthquake is called its magnitude. There is one magnitude for each earthquake. Scientists also talk about the intensity of shaking from an earthquake, and this varies depending on where you are during the earthquake. So, as I just mentioned, there are two scales used to measure earthquakes. The moment magnitude scale is the motion recorded with a seismometer, and it is converted into a magnitude number that represents the amount of energy released during an earthquake. That is shown here on the right side of this figure. Energy released for each whole number measurement is about 31 times greater than that released by the whole number before. So, for example, a magnitude earthquake is 31 times more powerful than a magnitude 1 earthquake. The moment magnitude scale is often referred to by the name of its predecessor, the Richter scale. Measurements on the modified Mercalli intensity scale range from 1, shown here, to 12, and are based solely on damage assessments and eyewitness accounts. Intensity measurements near the source of an earthquake are generally higher than those at a distance. Determining intensity can be difficult in sparsely populated areas with few buildings because intensity is calculated largely based on the effect that tremors have on human-made structures. How can scientists tell where an earthquake happened? This is done by looking at the amount of time between the P and S wave on a seismogram recorded on a seismograph. Scientists can tell how far away the earthquake was from that location. However, they can't tell in which direction from the seismograph the earthquake was, only how far away it was. Hint, this is important for your quiz. If you were to draw a circle on a map around the station where the radius of the circle is the determined distance to the earthquake, then you would know the earthquake lies somewhere in that circle. But where? Scientists use a method called triangulation to determine exactly where the earthquake was. See in this image. It is called triangulation because a triangle has 3 sides and it takes 3 seismographs to locate an earthquake. If you draw a circle on a map around 3 different seismographs, where the radius of each is the distance from the station to the earthquake, the intersection of these 3 circles is the epicenter. So I'm going to repeat this again. You have 3 seismographs. They each recorded the same earthquake. You then draw a circle around each of those seismographs where the radius is the distance from the seismograph to the epicenter of the earthquake. The point at which all 3 circles intersect is the source or the epicenter of the earthquake. All right, well, as I mentioned, this lecture was going to be fairly short. It is now it's finished. I would recommend all of you now taking your quiz 8A. And just a reminder, it is due Tuesday at 12 a.m. Not 11:59 p.m., but 12 a.m. on Tuesday. Good luck.